Yep. All right. Thanks for being here. Hello, everyone. And let's talk about GitHub tokens, Docker images, and workflows. Okay, I've just been introduced, so you know me better than myself. If you want to reach me out on the socials, here are my 3 links. So I'm a security researcher with a background in offensive security, as you may be understood by now. And I currently work at GitGuardian, a company specialized in secret detection and NHI governance. One pretty interesting thing is every year we publish a report that's called the State of Secret Sprawl, which goes into depth explaining and studying the state of secret sprawl, basically. It's backed with a lot of statistics and case studies around secret leaks and things like this. If you have never read this report, I encourage you to have a look. It's really great. It's non-paywalled, non-protected, completely free. And the new version for 2026 will be released in the few coming weeks. It's great. But let's dig into our topic, and I'd like to start with a quick introduction on how we came out with this topic and how we started looking into it. So basically in December 2024, somewhere around that time, GitGuardian scanned Docker Hub, more or less everything from Docker Hub, with slight simplification. Because Docker Hub is huge, as you can see here, it's evaluated to around 11 petabytes of data, so we had to reduce the set of things we scanned, but we ended up scanning 16 million layers from 15 million images and all the configuration from those images. And quite some work. And since then, we are continually scanning Docker Hub. And all over that time, so since late 2024, we detected 240,000 GitHub server-to-server tokens, which was quite of a surprise. It's a pretty big number, which made us think, okay, where do those come from? What's the issue with GitHub server-to-server tokens? And that's what we are going to look into today. With the first question, what is a server-to-server token in the first place? So I guess a lot of people here know GitHub pretty well, use GitHub probably. You probably already know a lot about GitHub tokens, which are used to reach and authenticate on GitHub API. Actually, there are 5 different types of classic tokens, which are different from the fine-grained token. Won't talk about fine-grained token today. With a very well-known one, which is the GHP, the GitHub Personal Access Token, which is used basically to authenticate a user, you, me, everyone. And a bunch of other types. One is a GHO for ho-host, there's a GHU, GHR, and one called the GHS, which is the GitHub server-to-server token. I asked my best LLM to define what is a server-to-server token. Basically, it's a token that will be used to authenticate an application against GitHub, a GitHub application. So basically, you register an application on your repo to do things, security scanning, for example, GitGuardian application. And this application will receive a token that it can use to authenticate on the API. So basically, those tokens are used for a wide variety of things. Basically, everything you can do with an application, there will be that kind of server-to-server token playing around. And one of those applications is a very well-known, very common, and very widely used one, and it's the GitHub Action. So here again, I'm pretty sure everyone knows what GitHub Actions are. If you don't, they are basically the CI/CD system of GitHub. So it's a workflow pipeline kind of thing. So a system that can run steps, build software, run tests, linters, things like that on your repo for a bunch of things. Workflows on GitHub are described in YAML files, like the one you can see here, without color for some reason. And those are stored directly inside the repository. And when you trigger a workflow under some condition, they will be run on what they call a runner, which is basically a server that will process your pipeline, build your software, and do things. One important thing is that in the action system of GitHub, there are off-the-shelf actions. So they have kind of a marketplace with pre-configured build steps. We'll see some in the next slides. And how does this work? So basically, you have your runner that will run the pipeline, that will receive the workflow configuration. It will then connect on GitHub API, do some things, clone maybe your repository, push artifacts, and so on and so forth. And to do that, it needs some kind of authentication. And so basically, this is where the GitHub server-to-server token appears. So your workflow uses a token. So basically, every time a workflow pops, it comes to life with a server-to-server token, which is quite limited token. So it's a short-lived token. So basically, when your workflow will end, your token will die. And they are scoped to the repository and have low permissions by default. So by default, this token only had read access on your repository, meaning you can clone your repo from your runner, which is quite useful. And those permissions can be configured, obviously, because you might want to do some more things than just cloning. And this can be configured either at the repository level, so you can click in the interface of GitHub and say, I want my token to have more privileges. But you can also do this inside your workflow directly. So you can say inside your workflow definition, I want my token to have write permission on the repository or some other thing. In the rest of the presentation, I might call this token GitHub token, because that's the name of the environment variable that is used inside the workflow to work with this default token. Okay, so basically you have this token that is used for pretty much everything. Every time your workflow wants to connect to GitHub. And yeah, workflows are used to build software, and this software is pulled from your repository. And to pull the repository, there is a very common off-the-shelf action. So one of those actions from the marketplace I was talking about previously, that is called actions checkout. It's a very common action that will basically pull your code inside the runner file system. And it uses the GitHub token to read the repository. It's basically equivalent more or less to a Git clone with the URL of your repo on GitHub and the token inside the authentication part. So it's sent over basic authentication, authorization basic, like in the good old web time. So in reality, it's slightly more complicated, but let's just consider it's a Git clone. So that's pretty nice, but there's a small catch. And this catch is this actions checkout will cache the token inside the Git cloned repository. So basically, when you call the actions checkout action, like it's done right here, you basically have a step inside your workflow that says, please call actions checkout, that will pull the repository inside your runner. You will end up with something like this, which is a .git/config file, classical one, with an extra section that contains the authentication information. And here, you can trust me, it's base 64 encoded, but there's a GitHub server-to-server token inside that file. Basically, this action is taking your GitHub token and pushing it on the runner file system, which is somehow fine because this file lives in the runner. Runners are isolated, so that's not really a leak yet. Because at some point, your workflow wants to do things it's a CI/CD system. So your workflow will want to build software, publish software, to create packages, to do things. And maybe, for example, create and publish Docker images, which is also a quite common use case of GitHub workflows. And the nice thing is Docker also offers an off-the-shelf action to build and publish images, which is called build push action, that look like this. So here again, we have two build steps. The first one being used to log in on Docker Hub so that you can actually interact with Docker Hub later, because nothing's free anymore. And then you have the call to the actual build push action that will take a build context and a Docker file and will build an image. It's pretty similar to what you can do with just the Docker command line, Docker build, Docker push. And yet you have this push flag that says that after your image has been built, you will push the image on Docker Hub, maybe publicly. So that's fine. And as I said, it's not very different from building an image locally. So there's nothing wrong with using this off-the-shelf action. And in fact, the security of your build depends on what you put inside your Docker file. So as long as your Docker file is fine, you should be fine. The thing is, there are some mistakes that a lot of people do that in that very specific context can have quite big consequences. And this issue I have in mind is this one. Maybe you have already typed this in a Docker file. Hopefully some people here write Docker files. So this mistake is the copy.anti-pattern. So it's a very common anti-pattern. We see it pretty much everywhere. I have here a screen capture from Docker, from GitHub. So I did this very little search for Docker files containing the copy.anti-pattern. And there are 1.4 million Docker files containing this. So it's very common. And what this does is that it will copy the whole build context inside a layer in the image. Basically taking everything you pushed in your build context and putting it inside a layer that will then live forever inside your image. Which can be bad in a lot of situations, but it's especially bad in our situation because the build context maybe contains the default token we pushed previously with the actions checkout action. So if we want to reconnect the dot a little bit, so we have here three parts. We have a workflow file with a call to checkout that will pull code on the builder, on the runner. We have another part of the same workflow that will build an image and push it on Docker Hub. And we have this simple Docker file that contains a copy.mistake. And what happens is when the checkout action is called, the token, so the default token will be pulled from the environment and pushed inside the repository clone on in the current working directory. Then we have the Docker build push action that will take the current working directory and push it as the build context to build the image. And the Docker file that will execute it will call the copy., that will take the whole context that now contains the default secret and will push it on in a layer inside the image. Last step, the build push action will take the resulting image that has been built and that now contains the secret and push it to Docker Hub. And that's basically how you end up leaking 240,000 secrets on Docker Hub. So that's a lot of tokens, but how bad is that? You might think it's not that bad for two reasons. Because first, the privileges set by default on the token are pretty useless. The default permission, as a reminder, was read-only access to the repository, which is completely worthless because if you leak your token, you also leak the Git repository that was surrounding it. So you already have access to the Git repository. So the token itself is just useless. And also there is this problem of expiration. When your workflow ends, your token expires. So it will just expire at some point. Let's see how things turn out when we look into it a little bit further. But there's some other. So on the permission side, I've already told earlier that you can change the permission set on a token. And actually people do this because if there is a permission system, it's because it's useful. So there are very common permissions that are widely set on tokens that serve some purpose. And I have listed here 5 different ones. So there's the contents permission that gives some permissions on the repository. There's the actions permission that gives access to the actions themselves, so you can change, modify the workflows. You have a slightly specific one, the ID token permission, that controls access to OIDC credentials. If you integrate your workflows with, let's say, PyPy, for example, you can authenticate your workflow using OIDC. And this permission provides this, but it's not bound to the token. It's completely different, so we won't be able to exploit it later. And the 2 last ones are pull requests to manage pull requests, and packages, which is used to manage permission on GHCR, which is basically the Docker repository of GitHub. And every single one of those permissions can be set to known, read, or write. And basically, if we want to be able to exploit a leaked secret, it must have permission, any of those 4 permissions set to write. So either contents, action, pull request, or package set to write, so that we can either write code to the repository, which would obviously be bad, push actions, workflows on this repository, merge pull request, or do other bad stuff on your repository. And so if you want to check if a given token has a good chance of having one of those permissions, you need to look into the workflow, and in actually 2 places. Because permissions can be set either globally on the whole workflow, like it's done right here. So the permissions here are defined at the workflow level, meaning that every job inside this workflow will inherit the permissions. Or they can be set more granularly at the job level, which means only this job will get the permissions mentioned, meaning right on packages, basically. Which means if you investigate this issue, it's important to really understand how permissions flow inside your workflow, because the job that calls action checkout must have interesting privileges, because that's the step that will actually leak the token. So that was for the permission set in the workflow. And as I said, the permissions can also be set at the repo level. So you can click and set the permission to write everything at the repo level, which cannot be easily seen either by looking at the workflow or looking at the Docker, leaked Docker image. But still, there can be hints in the workflow definition. So for example, here we have a small workflow that has no permission set anywhere. But that still calls git push at the end. So if it can push code, it's because it has the rights to do so. And so most probably the repo has been set to use write permission for everything. And similarly, there are some off-the-shelf actions from the marketplace that also recommend setting the write permission on the token. And so if you see those actions called, there's a good chance that the permissions have also been set. So permissions won't save us for this issue, or at least there are cases when the token will have interesting permission. And so everything that's left is the timing issue. As we said multiple times now, the workflow ends, the token expires. And so the question is, when will my workflow expire? When will my workflow end? And so my token expire? And to answer this question, there are 2 main things to look at. The most trivial case is the one when the workflow will continue execution after having pushed the image. There are a lot of reasons why this could happen, because you pushed an image to Docker Hub and now you want to deploy it. So you will call further steps to deploy this image to some environment somewhere. Or maybe you want to sign your Docker image, so you will have to compute a signed signature and then upload it, or some other things. And so while you are doing those things, your image has been published, the token has been leaked, but your workflow continues. And so your token is still valid. Here is a small example from a real-world workflow that calls build push actions twice, which is obviously interesting in terms of timing, because the first workflow might leak the token, while the second build push action will build an image and so take some tenths of seconds, maybe minutes or even some hours for big images. And during that time, the token is exposed and exploitable. Another typical example is this one, where you have first a call to the build push action that might leak the secret, and then you have a bunch of other steps to install cloud command lines, thingies, to deploy the image in production. So that's the trivial case. But even if you don't have anything run after you build push action, you might still have time to exploit the token. For one reason, that every step, every action you call inside your workflow can register a post action, which is basically a new action that will run before the end of the workflow in reverse order of execution. So for example, if you clone, I don't know if I have an example for this, no. So if you clone the repository, then call the build action before your workflow end, you will have a post action for the build action and then a post action for the checkout action. So every action triggers a post action, and those actions can also take time. Among the most common Docker-related actions that have post actions that take time, we find the setup QEMU and setup buildX action that are very commonly used if you build native application in Docker images, and also the build push action as a post action that will take time. And so here, for example, I hope you can see this. We have an example of the result of the execution of a workflow. So it's a pretty classical workflow. It starts by checking out the repository, then calling some Docker initializations, logging on Docker Hub THCR, then build an image. And that's where you have the 1 hour time. So here the image builds. And after that, you have the post build, the post login, post setup, post run action. And all those post actions take 30 seconds to run, which might be enough to exploit a token. In this other example, which is also quite classical, with nothing really fancy, we raise up to 16 seconds. All right, I have absolutely no idea how I am. Okay, how much time do I have? Okay, it's open bar on the timing. Perfect. So I'll try this demo, praise the demo god. So I have a workflow defined here, which is pretty simple. So it basically does what I've presented before. It checks out the repository, so leaking the token, log into Docker Hub, build and push an action, and then does some false deployment, so basically a sleep 30 seconds. Best deployment ever. The idea is it simulates an actual deployment, and it runs on the push action. Every time a commit is pushed to this repository, this workflow will trigger, and all the steps will run. And on the other side, I have an attacker script that will try to leak and exploit the token, and here, small command to just push some content to it. I'm going to open this action view, working. And I'm going to push a commit. Ha! Nice. Oh, come on. When you need to do it, you need to do it. Hopefully it will. Okay, it won't do it. Okay, that's better. So in theory, this should trigger the action, the workflow. It won't trigger the workflow for some reason. Okay, that's a failed demo live just for you. Okay, let me have a quick look inside. Should be working. Ah, it's actually running. Time to leak the token. Quick. It's race condition. Run. Maybe I was too fast. No, it's good. So in theory, so this just waited for the workflow to trigger. I'm just trying to figure out if it worked or not. No, it failed, just because I was too fast. Just going to run it again. No, pray I'm not too slow. Okay, it's better. So basically this will download the image that I've just pushed while the workflow is still running, find the token, collect the token, use it to clone the repository, which is a private repository here, and push a new commit inside the repository. And in theory, if that worked correctly, I should have now a new file that's called Git Guardian, and that says, "Ooh, I've pushed a malicious commit on your repository." Not the best demo ever, but it ended up working. That's really something. Okay, so that's an attack, and it works sometimes. Now comes the question: how do I change my workflow? How do I make sure I'm not vulnerable to this? And here comes the first good news of this presentation. Ta-da! This issue has been fixed somehow with the version 6 of Actions Checkout. So if you use Actions Checkout, I'm pretty sure someone here uses Actions Checkout, make sure you move from the V5 or lower to 6. Because now this action doesn't store the credential inside the .git config anymore, but in another place on the runner that is not in the current working directory. So you have zero chance to leak your token if you use Actions Checkout in version 6. Good news. And if you don't want to do it, or if you do it, but you still want to do some defense in depth, there are also a few good practices, best practices when building Docker images that you want to look into. And the first one is, it's really my favorite one, because no one knows this, but it's actually something. You don't need to call the clone action, the checkout action at all to build Docker images. In fact, the build push action is capable of handling, finding, downloading the context and building the image all alone without you calling the checkout action. It does so with not very well-known Git authentication for remote context mechanism of Docker build, which basically can pull your repository using credentials that you provided. So in that case, it will just use the default token. Get rid of all the downloaded artifacts, so there's no .git or things like this in the cloned repository, and build your Docker from this. It's the perfect solution. It's like avoids leaking the token. It also reduces the size of your workflow because you don't need to specify a context anymore. It's just so good. A second thing is you probably want to use a Docker ignore file. It's basically similar to a git ignore file, except that it's for Docker. And basically, it will control a list of files that will be excluded from the context when you call Docker build. In that configuration, you can put basically .git, for example, to make sure that your .git repository won't ever be pushed inside the build context when you call the build action or the build command line, if you work locally. You can also put your .env if you keep some nasty secrets there. And it's generally a good practice, even outside of GitHub Actions. And the last tip is, if you can, try using multi-stage builds when working with Docker, because that makes smaller images and also avoids some leaks. So basically what you'd want to do is to push everything secrets, whatever are inside a first phase, a first build phase that will actually build some artifacts, some software, some things. And then in a later phase, in phase 2, you will just pull the build artifacts inside your final image. Everything from the stage 1 will be forgotten forever. So if there was secret, disappeared. So that's pretty good. And you still end up with the result of your build inside the final image. So yeah, and if you, next time you write copy dot inside your Docker file, just think about me for a second. Something that is also quite important to remind is that the least privileges principle applies or should apply everywhere, including in GitHub Actions. So if you set permissions inside your workflows, which you probably do because you need them at some point, just make sure they are the least privileged possible. That's already something. And also make sure you apply the permissions at the smaller scope possible. So basically, you don't want to set up permissions at the workflow level, because that will just apply to all jobs, including some that would not need those permissions. So please only use job level permissions. And a corollary of this, split your jobs as much as possible. If you have a job that calls a linter and that builds an action, you're probably doing it wrong. Do 2 jobs, one that calls the linter and one that builds the image. Because that way your linter call won't get the privileges needed to build an image. And so you are separating the privileges, basically. Yep. There's a way to call actions checkout with a custom token, basically a GHP, a GL, PAT, whatever. If you can, just don't do it, because those tokens won't expire with the workflow and are likely much more privileged, including they can have cross-repository privileges that your workflow maybe do not need. They can need it, in which case it's fine, but if they don't, just don't do this. And final word for me, beware what you push on Docker Hub, especially if you work from private repositories. If you've seen my example, I was running my workflow from a private repository. And this private repository was pushed as the Docker image on the public GitHub. It's a breach. Basically, my private code was pushed to the public Docker because I wasn't paying attention to where I was pushing my image. And yeah, that's a private code leak. And we see that very often. So just make sure you are pushing to private spaces. And that's all for me.